Hey 6th grade, it's time for us to get going on lesson 1.3. Make sure your notes look nice and neat. Make sure your notes look, pretty much just like mine. Your notes are going to be a useful resource for you when we prepare for tests, so it would help a lot if you can read them. So at this time, I'm going to give you your little reminder of pausing to go get all of your supplies. You need to make sure you have your math binder with your textbook pages and blank sheets of paper in it, and also make sure you have a pencil. While we're going through our work, if you need to pause or if you need to rewind, if you miss something or you need some extra time to catch up, go on ahead and pause and rewind all you want. It's more important that you get all of the information and you're able to learn the information than it is, rushing through this. So take your time. Lesson 1.3 is titled Find and Apply Absolute Value. Find and apply absolute value. There you go. Find and apply absolute value. And once again, guys, we only have one vocabulary word for this lesson. So I know a whole lot of you are like, woohoo, yay! So our vocabulary word for this lesson is absolute value. And this is probably the first time you guys have done anything with absolute value. So the definition of absolute value is the distance from a number to 0 on a number line, and it's always shown by these two little lines that I'll put in my definition. Also, absolute value is always positive, no matter what. Absolute value is always positive. All right, there we go. Absolute value is the distance from a number to 0 on a number line. It is shown with these two little lines. It's like a little fence around it. And absolute value is always positive, no matter what. Our learning objective states, I will find and use absolute value in real-world situations. I will find and use absolute value in real-world situations. All right, and there's our learning goal. I will find and use absolute value in real-world situations. So next, I want us to go on ahead and flip through our math binders to our textbook pages. And for this lesson, excuse me, we will start on page 22, up there at the top where it says Build Your Understanding. Alright, so up here at the top of the page where it says Build Understanding, problem number 1, the story that goes with it, it says the elevations of 4 fish in a lake are shown. The elevation of the top of a lifeguard stand is 6 feet. Graph the integers on the number line. So I'm going to start up here at the top, and we have our lifeguard stand at 6 feet. The first fish in the water is at -1 foot. The second fish is at -3. We have -6 feet. And then the last fish is at -10 feet. So hopefully you get all that on your number line. Question A is asking, what is the distance from 0 to each elevation on the number line? All right, so -1 is 1 unit from 0. -3 is 3 units from 0. -6 feet is 6 units from 0. -10 feet is 10 units. And then, for the last one, 6 feet, the positive 6 feet up here at the top, it's also 6 units from 0, just like this -6. So make sure you pause so you get all of that in your notes. Question B. The distance from a number to 0 on the number line is called the absolute value of the number. Complete each of the following sentences using the number line above. So, the absolute value of -1 would be 1. The absolute value of 6, it's going to stay the same. It'll still be 6. Because remember, absolute value is always positive. So, the absolute value of -3 is positive 3. What would the absolute value be of -10? Hopefully you said positive 10. And the absolute value of -6 is 6. So, for C, this is where we start bringing in those two little lines, a little fence around things. The absolute value of a number is written with the symbols, those two little lines. For example, the absolute value of -8 is written absolute value of -8. Find the absolute values using the values from part B. So we have -1 inside of those two little lines, so the absolute value of -1 is 1. The absolute value of 6 would be 6. The absolute value of -3, because even though it's a negative number inside of those two lines, absolute value is always positive. So the absolute value of -3 is positive 3. Absolute value of -10 is positive 10. And the absolute value of -6 is positive 6. If you need to pause so that you can get all of this information, go for it. All right, question D. Negative numbers are less than positive numbers. Does this mean that the absolute value of a negative number must be less than the absolute value of a positive number? Explain. You need to pause your video so that you can think about this and answer this question. Negative numbers are less than positive numbers. Does this mean that the absolute value of a negative number must be less than the value of a positive number? And then we have to explain it. So in my notes, I'm going to say that no, the absolute value of a negative number must be less than the value of a positive number. No, it doesn't. And for example, if I said -7 is less than absolute value of 3. Well, -7 sure would be less than positive 3. But if I decided to write the absolute value of -7 is greater than the absolute value of, positive 3, that would also be true, because the absolute value of -7 is positive 7. So I could say something like the distance from -7 to 0 is greater than the distance, from 3 to 0. That's what I'm going to put in the blank for my answer. What do you have in there for yours? All right, now we're going to flip over to page 23, where it says step it out at the top. The magnitude of a number is its size or amount without considering its sign. That means without considering if it's positive or negative. The magnitude of a number is the same as its absolute value. I'm going to underline that because that may be handy information to know. The magnitude of a number is the same as its absolute value. So for question number, or for the information for all these questions under number 2, it says some insects produce a chemical that prevents the water in their bodies from freezing and helps them survive extreme cold. An insect's supercooling point is the lowest temperature at which it can survive. The table shows the supercooling points of several insects. Holy cow, some of these things can get really cold. Alright, so go on ahead and graph the supercooling points on the number line. And we have the pythid beetle with negative 54 degrees Celsius. Oh my gosh. Common banded hoverfly at negative 35 degrees Celsius. The New Zealand alpine weta, I don't know, negative 9 degrees Celsius. The pink rice borer, negative 6.8 degrees Celsius. And the woolly bear caterpillar at negative 70 degrees Celsius. We have a picture of that cute little thing. So when we graph the supercooling points on the number line, this number line is a little different than what we've been seeing before, because the 0 is way over here to the right, and then the number line is split up by tens, and they only label every 20 units. So take a minute to pause this and graph the points on the number line. Alright, so my marker got a little too whatever crazy here when I was graphing the negative 9 and the negative 6.8. But, okay, it'll work. So, question B. What are the magnitudes of negative 70, negative 54, and negative 35? And just like it said up here at the top, the magnitude of a number is the same as its absolute value. So basically, you just need to write the absolute values of these three numbers. I went ahead and wrote all three of those in the form of absolute value. So the absolute value of negative 70 equals 70, the absolute value of negative 54 equals 54, and the absolute value of negative 35 equals positive 35. Question C. Complete these number sentences which use absolute value symbols to show the magnitude of each number from part B. So we're already a step ahead. So we just need to put 70. The absolute value of negative 54 is positive 54, and the absolute value of negative 35 is positive 35. Question D. Write an inequality to show the relationship between negative 70 and negative 35. And this is when you will use greater than or less than. So I wrote mine to show that negative 70 is less than negative 35 because negative 70 is farther to the left on the number line than negative 35. And then it asks us which supercooling point is closest to 0 on the number line and explain. Well, that's going to be negative 6.8. And we can tell because it is the number that is closest to the left. It's closest to 0 on the left side. So it is going to, so 6.8 is going to be the supercooling point closest to 0. And then for question F, which insect has the lowest supercooling point? So we are going to come up here to our number line and we need to figure out which number is the farthest to the left from 0, which is negative 70. Well, when we take a look up here at our table, the woolly bear caterpillar is the insect with the supercooling point of negative 70 degrees. So we are going to put woolly bear caterpillar in this blank. So we're done with our textbook pages for now. And we're done with our notes also. So go on ahead and make sure that when you are finished with your notes and finished with this video, that you go to our Into Math HMH website so that you can complete and submit the Check Understanding assignment. Just like usual, I need to be able to see what you understand from the lesson. And you need to make sure you submit it. Otherwise, I'll never know if you did it or not. Alright? So I'll see you guys later. Bye.